Okay, welcome back, 6th grade. These are, now we're into session 2. So this just under the booklet, the title is session 2, and the first one is number 32. We're going to read through these, discuss them, show lots of different ways to think about these, and really exercise, that math problem solving muscle that we have. It's just really important. Let's talk all about these. Okay, we're going to go with an orange color. Going with the orange today. Here we go. Which set of values makes the inequality n greater than or equal to -5 true? So an equality, just going to show you really fast, equality would mean something like, 2 plus 3 equals 5. There's only one solution. So an equality, there's only one solution. In an inequality, there's a lot of values for n. So it says, let's pick a number that's greater than or equal to -5. So there's lots of things that would fit. And where you see something like this is that, would make this statement true. In other words, maybe you're building something and, or let's say you're painting. So you can paint as long as the temperature, for example, is greater than or equal to 50 degrees, usually with paint, okay? If it's less than 50, then the surface, it doesn't absorb paint and the paint doesn't react very well. So greater than or equal to 50. Of course, now, technically, it's not really going to go up to it's not going to be 400 degrees outside. You wouldn't be painting, but that's an example of an inequality. Okay, so let's look and see how that works here. Okay, let's get this. Come back, pick that up. All right, so which set of values? Okay, so all this means, these little guys here, just means a set. It just means like you have a set of toys. It's just a set of numbers. So the easiest way to do these is to go ahead and put them on a number line. So you make a number line, and let's go ahead and we'll put 0 in the middle because it looks like we've got a -5. We'll go backwards 5. 1, 2, 3, 4, 5, and -5. So this one says n is greater than and then or equal to -5. So it can be equal. Well, when you want to show that something is equal, you make it as a solid color on your number line. We'll go with a gray. A solid color. Ooh, that's not a very dark. Not a good choice. Solid color on your number line like this. Okay, and then it says, so that's this part. And then it says everything that is greater than that. Okay, so I'm going to go back, use my orange, and put some more numbers. I'll go up here to 1, 2, 3, 4, 5. Okay. So everything that's greater than 5. So that's what you have to know on a number line. As you go to the right on a number line, numbers are getting larger. The value of the number is getting larger, I should say. The value, right? Now, even though here, remember, this is -4. Whoops, didn't pick up my darn. Second here. See if that gave it to me or not. Nope, doesn't want to give me that color again. There it goes. Even though the digit -3, -2, -1, even though the digits are getting smaller, the value of -4 is still higher. If you think of it as temperature, -4 degrees is higher than -5. So as you go to the right on a number line, the numbers are getting larger. The values are getting larger. As you go to the left, the values are getting smaller. That's another one of those big ideas in math that can save you. It can really save a lot of time on things. So we're going to actually, it says greater than, so we're going to go to the right on the number line. So all we do is go out here. And it doesn't tell us to stop. So we could just keep going all the way, draw a line right out your room, out the window, down the street, because it's like n is greater than or equal to -5. So it's all the way this way. But don't do that, okay? Don't go out in the street and draw a line, okay? Because that probably won't be very popular. Okay, so let's look at these digits. So is -5 on our number line? Yeah, that one works. -5 and 5/10 and -6. Those values are over here. So this is not going to work. -5, that's on our number line over here. -4 and 5/10. Yep, yep. This looks really good. That looks really good. -6, no, because we're not going this way. That one's out, and that one's out of there. The answer is B. Okay? Don't forget those big ideas. Big ideas are what shape your thinking when it comes to problem solving. Okay? That's what gives you the ability. Let's look. Okay, this is a fun one. It's got a percentage in here, so this is going to be a lot of fun. An ice cream shop sold 48 vanilla milkshakes in a day. So 48. Which was, in other words, this 48 vanilla milkshakes was 40% of the total. Okay, so this 48 represents 40%, not all, right? 40% of what they sold. Okay, what was the total number of milkshakes sold that day? All right, so again, I'm going to take this information out of here and put it in a bullet form. I have 48. I'm going to put vanilla milkshakes. That's all I need to put. And then I have 40%. That's 40% of the total. And then the question is the total. I don't know what the total is. Okay? All right, so I've got some relationships here. First of all, I got 40%, which is easy to write. So let's put that one down. And remember, the big idea, again, these big ideas, this is parts. When you talk about a percent, the big idea is you have a part and you have the whole. So in this case, we have 40% is the part. That means 40 out of 100. The 100 is the whole. And the easiest way to set, well, not one of the easiest, or there's several, but with percents, then you can think of the big idea. You have part and whole. You can also think of equivalent fractions or ratios. So we can set up an equivalent ratio over here. So the ratio of 40 to 100 is, let's go back, 48 milkshakes. 48 vanilla milkshakes, that represents 40. So in other words, 40 is to 100, just like 48 is to the total. So now you basically just have two fractions here. You could think of it as two fractions. They're in fraction form. So now you can say, well, let's see. Let's go the easy way. Can I do 40 times anything equal 48? No. But another big idea is simplify. And so you always want to simplify things, which makes sense. You want things to be simple, right? So let's simplify this. Let me make a little space here. Let me take this guy back off. So simplify, because I'm going to need this space down here. So I have 40 and I have 100. So I could divide each one of those, like 40. Let me come down here. I could do 40 over 100. They both end in 0. I could just divide it by 10. Okay? And that would give me 4, right? 40 divided by 10. And 100 divided by 10, 4/10. I could go further, but you know what? That's going to work for me. So let's make the math work for you. Okay, make the math work for you. So, O is the same as, whoops, that's 48. 48 over the total. So I can get this right away. So now, easy thing to do is I can say, okay, 4 times what? 4 times what equals 48? Okay, that's going to be times 12. So this can also be times 12, because I'm basically making an equivalent fraction, which means I have 48. 10 times 12 is 120. So the total milkshakes would be 120. All right? So that's just one way to do it. Let's kind of look over there and take a look. That's one way, 40%. You could get rid of a couple of answers because 40% is less than half. So could this be the case? Could I have 48 vanilla milkshakes and have served a total of 60? The answer is no way, because what this is telling me is that the vanilla milkshakes are less than half of the total. So you could get rid of that one right away. You could also get rid of that one right away. Okay? You could also get rid of this one, because if they'd sold a total of 100 milkshakes, think about this. We could have done this whole thing without even showing any work. Look at this. 100. If they had done 48 vanilla milkshakes, and if this was the 100, if this was the total, that would mean that the vanilla milkshakes were 48%. But we know they weren't. They were 40. So you could think of it that way too. So we actually could have gotten rid of everything and not even done any work. That would have been kind of cool. Okay, let's look at one more way to do this. There's another way also, really fun. If you have I don't know if you have a calculator on session 2 or not. If you did have a calculator, you can use another big idea, and that is you can turn all numbers can be represented in as fractions, okay, as whole numbers, or sorry, fractions, percents, and decimals. So what's the decimal form here? Ooh, hold on, let me pause this. Let's get a different color here. So another big idea is that fractions can be, that numbers can be fractions. Okay, they can be percents and they can be decimals. So the decimal form here, this is supposed to be a D for decimal. So 40%, 40 hundredths, decimal form. 40 over 100 is just this, right? That's 40 hundredths. So it's telling us that 48, this is what it's saying here, is 40% of the total. 40 of times the total. Okay, so another way to do this is say, oh, okay, well, 48 equals 40% of the total. And this might be a little harder for you to see because I guess I forgot. Maybe we haven't done the algebra, but anyways, you can solve for this. We talked about in the video right before this using inverse operation. So this is 40 times the total. So you could divide by 0.4, by 40 hundredths, but you have to divide both sides of the equal sign by 40 hundredths. Okay, and if you get your calculator out and you divide 48 divided by 0.40, you will get 120 equals the total. Just another way to do that. Pretty cool. Okay, welcome back. Okay, 34. I just moved down to 34 down here. So which expression, we talked about that. An expression is not like an equation. It does not have, if you notice along here, it does not have an equal sign. So, they're kind of picky on things like this. When you take a test or a state test, if it says expression, just don't use an equal sign. Okay, which one represents the phrase below? 3, and this is the trickiest one that we have here. 3 fewer than a number. 3 fewer than a number. So a lot of times what you're saying here is you're saying 3 fewer than a number p. So let's say we have a number like 6. Just think about this. This is kind of a backwards way of doing it. If you have a number 6, what is 3 fewer than 6? Well, you wouldn't write 3 fewer 3 minus 6. Okay, we wouldn't do that. Instead, what you say, 3 fewer than 6 would be 6, 3 fewer minus 3, or 3 less than 6. Okay, and so a lot of times this gets confusing because students will read this. They'll read something like 3 less than, and then they'll say, oh, that's 3 minus 6. But this is saying we're 6 less than 3, like 6 lower than 3. Think about that way. So what are we talking about here? Let's go back to this. Let's go back to this one. 3 fewer than p. What you could think of is 3 numbers below this number p. So you'd have to say, you have to start with p and say minus 3. That would be the correct one. Okay. You could probably get rid of these two really easily, right? P divided by, no. But it's letter A that gets a lot of kids, okay? All right, so think of it as when you see 3 fewer than a number p, you have to stop and think in your head, well, what's going on? Use that problem-solving muscle and say, well, if I have make up a number and say, well, let me test it. If I have a number like 6, what would be 3 fewer than 6? Oh, Okay, so you want to think through. That's how you work through some of these. Don't just grab, write an answer, then say, oh, good, it's over here, so that must be it. So be really careful about that. All right, we've got number 35. This is a thinker here. This is a thinker. So it says, what number is not part of the solution set, okay, to the inequality shown below. So remember, we talked about inequality. Inequality is something like 8 plus 8 equals 16. There's only one solution for that, okay? It's just equal. An equal sign basically is like a teeter-totter, okay? It's like imagine a teeter-totter, and over here you got these two seats, and here inside this seat, or on this side, you have children 8 plus 8. You have number 8 and another guy. They're twins, 8 plus 8, and over here you got the big brother, 16. So together, that teeter-totter is exactly equal. There's only one thing, one solution to that, okay? But in this case, we have W minus 10, not equal, just it's less than or equal to 16, okay? So we had to figure that out. So in the last video, we talked about putting this on a number line. So you can think of a number line, okay? And we can kind of start with, we've got this value of 16 out here, okay? So which values for W, okay? Actually, let's do it this way. So which values for W, I don't know if we're going to make it work this way or not, are less than or equal to 16. Okay, so in this case, you could solve for that. You could also just come over here and say, you can test these answers. This is a great way to do a lot of problems. Just test the answers and see if you can save some time. All right, let's see. What about 11? Let's put 11 in there. So this time I'll come down here and I'll try 11, okay? And instead of W, I put 11. Okay, that's what we're trying to find. We're trying to find what could fit in there for W. So is 11 minus 10, is that less than or equal to 16? Well, 11 minus 10 is 1. Is 1 less than or equal to 16? Absolutely. But remember, we're trying to find the one that is, so that'll be the part that'll trick a lot of you probably. Okay, so that one works, but we're looking for the one that does not work. How about, let's try the next one. How about 15, okay, just pick a different color for each one of these. 15 minus 10, is that less than or equal to 16? Well, 15 minus 10 is 5. Yes, 5 is less than or equal to 16. We're looking for the not, though. And now you're starting to see, oh, these are really close here. What's going on? What's going on? So let's test them, okay? So this is 26. Oops, different color. Thought that was, but. So 26 minus 10, is that less than or equal to 16? Well, 26 minus 10 is 16 if you do the math there, and 16 is less than or equal. Now you might say, well, wait a minute, that's weird. So 16 is not, it's not less than, but it's okay because you got this sign down here. It is equal, so that works. So now the question becomes, well, now you know. Now we got it, right? We nailed it. We got it. We don't even have to do the last one because 27 minus 10 is 17, and that is not less than or equal, okay? So there it is. Nice job, nice job. All right, let's look at 36. 36. So again, these are just all problems all over the place. Okay, let's take a look. They're when I mean all over the place, they're all different types of things that you've looked at before. So this says the coordinates. You got to remember what a coordinate is of the vertices. That's just a corner of vertice. In other words, like if you have a shape like that, that's a vertex. These are the vertices. I'm circling the corners. One is called a vertex. That's just one. And a bunch of them together are vertices. Just a corner. So the vertices of a triangle ABC are 1, -1. B is 1, 4. C is 8, 4. Okay. What is the length in units of the line segment connects vertex A and vertex B? So we're looking for the length of a line segment. So way too hard to do like this. So let's just graph it. So the easiest way to do it is just make yourself a graph. Make a coordinate plane, I should say. Okay, with your x and y axis. And they don't give you enough room here, clearly, but let's just go out 5. I think we can go out 5 for the most part. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that would be -5, and that goes out to 5. Okay, this one is 0, and then we're going to try to keep it the same. 5 down. 1, 2, 3, 4, 5. That is negative. Well, I'll do it over here. That is -5. Get rid of that little line if I can. Oh, wrong thing. Nope, there it goes. Okay, and then 1, 2, 3, 4, 5. Okay. So we're going to graph this thing here. I'll get a different color. We'll go with this part right there. Did we get it? Nope. This one. Okay, so we're going to graph A is over 1. So remember, this is what's going on here. So this is the x and this is the y. So x comes before y. I should have labeled that. Ooh, not good. There's x and y axis. Okay, so the first one is over 1. So if I put them on this little chart here, it's 1, -1. That's going to be A. B is 1 and 4. And C is 8 and 4. But I don't think we have to even worry about C. We're just worrying about these two guys, okay? All right, so we're gonna go ahead and graph A and B, right? So the coordinates of the vertices, so the coordinates of the corners of this triangle, here they are. We're going to graph those. We don't need to graph this one because it says, what is the length in units of the line segment that connects vertex A and B? In other words, that part of the triangle. So let's do this one. Over 1, remember that's, you go either left or right first. Your x variable first, your x coordinate first, I should say, and then you go up or down. So we're going to go over 1, down 1. So over 1, I'll start at the origin, over 1, down 1, right there. Okay, and that is A. Then I go over 1, up 4. So over 1, 1, 2, 3, 4. And that's B. And so the question is, how long is this? Okay, and I should have gone right through that little guy right there. It's hard to draw it. So I'll try to fix him. So technically he's right sort of like this. Oh boy, gonna run into trouble here. Oh, there we go. Hold on here. Okay, I had to shut it down and show him who was boss there real fast. All right, so now we've got, so here is, this is the line segment. Remember, there's another one way out here, C, which is like 5, maybe like 6, 7, 8, and then maybe it says go up 4, so maybe it's like out there. But we don't have to worry about him, okay? But that's what our triangle looks like. But we're just looking at B and A. So what's the distance? It says, what is the length in units of this line segment? So really, we're just counting down. We're going, it starts here. It's 1, 2, 3, 4, and one more 5. So the length is 5. Now, how do we know that? Well, remember up here, this was 1, over 1, and up 4. This was over 1 and down 1. So we can also just look at these two coordinates and we can say, oh, so the absolute value of this one is, how many units is this one from 0? And it is 4 units from 0. And then how many units is this coordinate from 0? 1. So I have to come down 4 and one more. So come down 4 and one more. That gives me a length of 5. Okay? Good job.